All right, we're back. 2014 build. Anders Hejlsberg, how are you, man?
Good to see you, Charles.
It's great
Always
to see
a pleasure.
You.
Yeah.
Always.
Yeah.
Huge news today.
Yeah.
Incredibly excellent demos and announcements. Let's talk a little bit about what it means to have Roslyn open source and C# as open source. Tell us a little bit about this.
Well, what it means technically is that anyone now can have a C# VB compiler and a language service just by cloning our repo on Git on Codeplex,
sure.
Using Git or TFS or whatever, right?
Sure.
Of course, for the community, I think it's going to be big.
Yeah.
There's always been this, oh, is Microsoft going to enforce their patent policies? Can I this, can I that? And we're really trying to show the community that we understand what a huge investment they've made by using C# and .NET, and we're willing to play and also invest in that and allow people to run their code wherever they need to run it.
Excellent.
Because clearly, it doesn't just need to run on Windows.
Absolutely. Right? I mean, that's just amazing. I mean, I know that Miguel and the Mono group is actually more than Miguel, right? There's a lot of people in the Mono community have been doing a lot of work for 12 years.
Yes.
And they love your language.
Yeah, and we love what they do.
Right on, man.
I mean, it's fantastic. Yeah.
Cool. So, in some sense, because C# is implemented on top of Roslyn, if you will, in terms of the compiler technology, it's really easy to add new features. Is that fair to say? Well,
I showed on stage that with 3 lines of code, you can add a new kind of string literal.
Sure.
So obviously, it is easy to add features.
Yeah.
It may be a lot harder to get us to take a pull request for those features.
Right on.
I mean, we're still going to apply the same filter that we apply to ourselves when we consider new language features. And that's a pretty high bar. Because the thing about programming languages is you can add to them, but you can never take away, at least if you care about backwards compatibility, and we do. So we're going to be very, very conservative when it comes, but we will look at pull requests just like we will look at our own ideas, right? And
awesome.
So, yeah, so we're trying to engage the community here.
Great. And there's lots of smart people out there. So
There
the potential for innovation.
Yeah, you bet.
So we have, obviously, this is all about the people in the audience. Ask questions. Very easy to do. You see us right here. Type in right there. N wants to know, are you planning to add support in the future for translating from C# VB.NET to TypeScript with Roslyn?
That would be tricky. I have demoed before using Roslyn to translate from C# to VB and from VB to C#, which is just a syntax tree transformation. Translating to TypeScript is a semantic transformation in the sense that you would also have to transform all the calls that go to the .NET framework into some equivalent in a browser, and that is much, much harder. In fact, that is darn near impossible to do with any level of fidelity that's meaningful. So if you want to use C# to write code for the web, there is an open source project out there called ScriptSharp that you could consider, which cross-targets to JavaScript. But you're using C#, the language, to write for a web target. And you're really, in a sense, using a modified version of the framework, whatever. Or you could just consider using TypeScript. I personally feel that if you're going to write for the web, write for the web. Don't write for something and turn it into the web. You're never going to get best of breed that way.
Exactly.
So
good comment. Hey, Eric Lippert, man, really nice to see you, at least virtually. So Eric's asking Anders, now that anyone can modify, build, and distribute C# and VB compilers, do you anticipate the languages fracturing into dialects?
I don't. I mean, it depends on what you mean by fracturing into dialects. I do expect a lot of people to experiment with new language features and maybe even write code. And sure, some might do the math and decide that for us or for our group or for our organization or what have you, it makes sense for us to build a dialect of the language, and we're willing to commit ourselves to maintaining it forever in our own fork, but I think, in a sense, this is how innovation is fostered, right? I mean, you got to give people something to play with if you want to see any kind of new ideas being born.
Sure.
But with the .NET Foundation and the Roslyn code base having a pretty high bar for accepting pull requests or whatever, we're still going to continue to be the stewards of the language, and we're going to act responsibly, just like we've done before. Yeah.
True, but of course, like if I were to like, if somebody was able to say, I'm going to create C##, and I'm going to add destructors to the language, or I'm going to add some deep features, and I'm capable of implementing that, then all of a sudden we have a C## that isn't sponsored by Microsoft, but you can still download and use it inside of the IDE. So that's sort of, I think, what he means by fracturing.
Right, and I think, in a sense, the community gets to have the final say, right?
Cool.
Let's say that someone does that, and that everybody starts using that. Well, there must be something good in it there, then, right? I mean, and then we got to start considering it. But so yeah.
Understood.
We'll see. I will say too, this is going to be a learning experience for us. We have this. I mean, obviously, the C# compiler wasn't open source before, so
it's amazing. I mean,
so we're going to learn.
Are we still Microsoft? All right. So Shaggy wants to know. I noticed on the new Roslyn page, the scripting REPL was not included in today's release. Can you please speak on when this will be added back? Great job, Roslyn team. Today's news.
Thank you. That's right. It's not in that end user preview that we put out today. We are planning to have it in the next version of Visual Studio. If it's really just a matter of managing all of the work.
Sure.
It's on top of our wish list. I believe we'll make it, but
right on.
I can't commit.
Good. Putting Anders on the spot. So Rabbit Coder, with new approaches to type system, C# having optional dynamic and TypeScript optional static typing, which one do you find more flexible and futuristic, both from users and a scientific standpoint?
That's a good question. It's been very interesting to work on the TypeScript project because traditionally, type systems have sort of been an on-off switch, right? It was either you're in a dynamic language that doesn't have a type system, at least not a static type system, at all, right? Or you're in a statically typed language where everything has a known type and there's no in-between, right? TypeScript, in a sense, has turned that switch into a dial, right? And it gives you optional static typing. You can type it as much as you care to, and we will check those parts, but other parts of your app can just be unchecked, if you will. And that turns out to be super meaningful because it may not be worth it for you to, like, if you already have a bunch of JavaScript that works, well, okay, let's not force you to go add static types everywhere there. But for the new code you write, you may want to write it in TypeScript, and so having that be a dial is very interesting, and it's very interesting from a scientific or academic standpoint to explore this notion of gradual typing and what kind of guarantees can you provide in tooling when you don't know all of the types, and you want to do refactorings and so forth. So that's been it's been fascinating. I wouldn't say that there's one or the other. I obviously love C#, but I also really like coding in TypeScript. They're both fun languages.
So in terms of optional typing, that seems to be sort of in vogue today. If you look at Hack, by Facebook, and of course Dart, and of course TypeScript. But is there any thought of like adding an optional type system to C#?
Well, I mean, C# has some optional typing through dynamic, right? I think that's where we're going to leave it. We may look at perhaps making dynamic coding in C# a bit less heavyweight. I mean, what happens today when you use the dynamic type is that we basically have to then include a runtime binder that can bind your dynamic calls, and that actually turns out to be sort of half of the compiler's type checker that needs to sit in your program at runtime.
I see.
And that may be a little heavy if all you're trying to do is just read some dynamic JSON and have a nice dotted syntax for accessing it. So we're looking at ways that we can make dynamic more lightweight, so to speak.
Awesome. Yeah. All right, so Sonny wants to know, what should we look forward to in the REPL scripting hosting department of Roslyn, and how soon it will release? Apparently people are hungry for REPL now.
Yes, I understand that, and like I said, we're furiously working on it. We had to prioritize things, getting Roslyn ready for OSS was actually a lot of work. I mean, you got to clean up all those comments that might be offensive to somebody, or
were there
or
any
whatever.
killer
Or just
comments
no, I don't think so. But it just getting it all and really just moving our whole workflow to being in an open source repository when we check in code and whatever. It just all takes time, right?
Absolutely.
We love REPL. We love interactive. We want it to be in the product. It's going to be there as soon as we can get it in. Yeah.
Did you find yourselves doing a lot of refactoring before going open source? So So taking your code base and doing more refactoring to make things easier
Well,
to understand
I mean, it's like you want to put your best foot forward, right?
Sure.
And you put your work out there. And so all of these things that, oh, well, I really should come back and look at this, and this needs to be cleaned up. And, well, this might be the time, right? So yeah, you know.
Right on.
Yeah.
So Oscar wants to know, because you've been working on JavaScript for so long, do you see JavaScript as the language of the future, even for server-side code? JavaScript is the language of the future, we ask Anders Hejlsberg.
Well, I don't think there will be one language for the future. I think we've all learned that lesson by being in this industry for long enough. I think every language has its natural affinity, if you will, or center of gravity. For JavaScript, that is obviously the browser. And the browser is what's going to dominate, JavaScript's evolution. Now, JavaScript, though, can be very useful on the server, and there's some great execution environments for server-side JavaScript like Node.js, which we actually support in TypeScript too, and it's a super experience, but it's a much more nascent framework compared to, it's only in the few years old, right, where, .NET is now 15, Java is like about the same age, right? These are more established players with much larger frameworks, and perhaps also more of an affinity towards the server, right? So it's just you pick the right tool for the right job. I don't think there's one, but of course, one thing JavaScript has going for it is that it's pretty much the only thing that runs everywhere at this point, right?
Sure, absolutely.
Yeah.
So TypeScript 1.0 you announced yesterday in your talk, and that means it's now officially out. Right?
That's right.
Is that what 1.0 means? The official release.
Yes.
And so,
of course, when you're open source, what does that mean? What does that really mean? Yes.
Okay.
But I will say what it means is this is the one that we're committing to supporting in a backwards compatible manner going forward. Right.
Okay.
Before 1.0, and in particular from 08 to 09, and the 09 releases. Based on feedback from the community, or basically just having bugs in our code, we had to tighten things up, and then we would break people's source code. We're not going to do that anymore. We're committed to, this is what we're going to carry forward.
Great.
And that's really, to me, what 1.0 means.
Perfect. Yeah. So that was the answer to your question, Brent.
Well, actually, I should also say, it also means that it is now a first-class supported language in Visual Studio.
Cool.
Alongside with C#, VB, F#, and so forth. So you should expect to see the same level of support for TypeScript in there that you see for
and
these
you guys
other
have
languages.
made some optimizations in this release for performance in terms of large projects?
Well, 1.0 has mostly been, I would say, from 09.5 to 1.0 RC to 1.0, it's really mostly been about squashing out the bug tail and getting stability, performance, to the level that we wanted it to be. Yeah.
Excellent. So Robert Sundstrom, what about implementing code contract language features, ensures and requires statement like inspect sharp in the C# and VB languages themselves?
Yep, it's something that we've looked at on many an occasion. We have so far felt that we weren't sure that it was worth the syntactic overhead of having it in there. You can do a lot of the same stuff by pre-processing code or by having basically APIs that emulate requires and ensures, which is a methodology that we've actually used in the BCL, the Basic Class Framework, Basic Class libraries in our source code there. But it's something that we continue to look at. Again, it's always tough,
Sure.
because when you add something, it's there forever, right? And it just and it only makes things more complex every time you add, right? So
Understood.
we just got to be.
The smart programming assistant that MSR is working on is quite interesting as well.
I'm not sure I've seen that one.
It adds sort of deep code analysis inside the IDE using C#.
Okay, yep.
That'll help you, that runs through it's basically unit testing built in at the functional scoping level.
It's interesting because with a technology like Rosted now, where we're, in a sense, democratizing access to the knowledge that a compiler has about your code, right?
Right on.
And that, in turn, is going to enable people to build higher level analytics and diagnostics on their code. Like an example here that we all know is FXCOP, right?
Sure.
Which is obviously all of FXCOP's warnings. You wouldn't want them to be compiler errors, but you kind of want to run it in the same way that you run the compiler and have errors and then whatever and squigglies show up, right? And now, in a sense, we're opening that up so anyone can build diagnostics. But they can do so without having to first write their own C# parser and then analyzer and type checker, right? Which is a non-trivial task,
totally.
Obviously.
And of course, the smart programming assistant that I mentioned is based on Roslyn.
Right.
So
right.
It's an example of...
Yeah.
So is there any research happening into ASM.js for a possible .NET migration path to the browser?
For a possible .NET migration path to the browser, I don't think anyone's thinking about that. We're certainly keenly aware of ASM.js. Mostly, I think we view that as a way of running sandboxed C code in your browser. You know, you can use a toolset called mscriptum, for example, to translate C code into ASM.js compliant JavaScript that you can then run in an ASM.js aware browser and get very close to native performance. But of course, you still don't get, but it's interesting because whenever you see these like benchmarks of, oh my God, ASM.js was within 1.5x of native. Yeah, but it's sort of in an orchestrated environment where there's no use of multiple CPUs or threading, or there's no use of the GPU. And if we all look at what it is we do in our native code to really wring out that last eke of performance, right? It's actually about using multiple cores and using the GPU to really get the speed of them. Of course, ASM.js can't do that. You know,
absolutely.
So, but it's an interesting project.
For sure.
Absolutely.
So speaking of near native performance, yesterday we kind of slowly, quietly launched .NET Native.
Right.
A preview of taking IL, passing it to the VC++ backend compiler.
That's right.
Getting highly optimized code.
That's right.
So that's really cool.
Oh, it's something that's been on our wish list for the longest time, right? I mean, JIT compilers are amazing, and they have a number of really fantastic inherent advantages, like the ability to do dynamic reflection and code generation in a program is awesome, right? And something that you just simply cannot do in a C++ code base, right? And if you look at how much we rely on dynamic code generation and instantiation of generics or whatever, you know, at runtime, it's like, it's everywhere, right? But it does mean that when you take out your phone and you fire up that app, you know, you're going to be spending a bunch of cycles jitting that same app over and over, right?
For sure.
And really and that's directly, you know, measurable in the amount of time it takes for the app to come up and the amount of battery it sucks up whilst you're doing it, right? And so, in order to ensure higher responsiveness, a whole class of apps, particularly on client mobile devices, don't really need these reflection capabilities.
True.
They're simple apps, or they just don't do dynamic stuff, you know, and so we can do a lot better by compiling them, even compiling them in the cloud maybe, or compiling them before delivery and then simply delivering an exe, right? Because ultimately that's what runs.
Exactly.
You know, it's just a question of where does the compilation happen, right?
Yeah. And of course, there's still guaranteed type safety and garbage collection.
None of that changes, yes. Semantically, these programs are the same. There are some restrictions with .NET Native as to, like I said, what kind of reflection can you do? You know, in a sense, you sort of have to opt into it, and you have to say which things do you want to be reflectable. You know, because otherwise we can't do what's known as tree shaking. Tree shaking is this notion of, after the fact, you look at all the code that is in all of the assemblies, and then you go, well, this code is never used, this is never used, this is never used, I'm going to get rid of it and then produce an exe.
Nice.
But of course, if you can reflect potentially on anything, well, then we got to include everything, and now your exes get ginormous, right? And so there has to be some involvement there up front where you say, here are the reflection routes that I want to include in my image, you know, and then we can tree shake based on that and then give you the smallest possible executable.
Awesome. So now we're going to go back to questions. We have a lot of them. Thank you for asking them. Z wants to know, why is there no unit testing framework for TypeScript and Visual Studio out of the box?
That is a good question that I don't know the answer for.
So AS wants to know, as a follow-up to Eric Lippert's question, if some of the extended features are used extensively, do you consider merging the changes upstream?
Yes. I mean, in a sense, you know, if people create forks and get a lot of excitement around particular language features or whatever, well, then obviously the community is voting with their feet, and then we're gonna want to consider it, right? I mean, awesome. We're all in this together. I'm not here to like tell you, you know, you can't have this if everybody wants it, right? So
great.
Yeah.
Awesome. It's nice to see this level of openness. So Asaf wants to know, what is Microsoft's answer to AngularJS in terms of HTML5 SPA framework?
Well, I wouldn't say that we necessarily have an answer. We have, you know, one framework we have is WinJS, which is for writing Windows web apps, or WWA apps for Windows 8, right, or 8.1, which we open sourced yesterday. And actually that framework works in a browser too. You know, and then so you can use that. It's really more about design language, if you will. You know, you can use it on other devices. So that's one possibility. We like Angular. I see a lot of people using Angular with TypeScript. I see a lot of people using other frameworks with TypeScript. In a sense, I don't know that we have an agenda here necessarily. It doesn't really matter. I mean, these things are open source, right? I'm just excited to see, you know, that, for example, Angular has great support for TypeScript because of all of these definition files that have been collected on Definitely Typed, the GitHub site that collects, or a repository for definition files for TypeScript, and there's great ones for Angular, for jQuery, for, you know, 350 different JavaScript frameworks, you know. So
amazing.
So pick and choose.
Rock and roll. That's, I mean, it's. So Frank wants to know, what is your opinion on the idea? We're a lot of TypeScript questions. I'm impressed. What is your opinion on the idea of including async await into TypeScript, which is a really wonderful language feature?
I would love to do it.
Okay.
It's, you know what, if we can find the time. The TypeScript roadmap basically is, so today or yesterday, we released 1.0, right? Next on the roadmap is ECMAScript 6 parity. ECMAScript 6 is slated to be ratified in December of this year, so towards the end of the year, if all goes according to current plans. And there are it's a fairly big release of the language. There are a whole bunch of different features in there, and obviously we want to support all of those in TypeScript with static typing wrapped around them, right? So we can reason about generators, and we can reason about destructuring, and let and const, and all of these other features that are in there. Once we get that done, I'd love to also somehow find time to look at async await. It turns out that once ECMAScript gets generators, which is a proposed language feature for ECMAScript 6, and it's going to be adopted, no doubt, then it's actually quite easy to translate asynchronous methods and awaits into JavaScript generators.
Okay.
And that's likely the path that we would take. And then really the value we would bring is that we would allow you to write things as functions instead of generators with awaits in them, and then we would get all the types right for you. You know, because as a generator, the types don't work out. You know, you're really more using the generator as a means of moving your state machine forward. But the way the types work would be different. That would be very interesting work to do. It is theoretically possible to generate code for down-level browsers with async await, but the problem with it is that it completely mangles your code in all but the absolute simplest scenarios. Okay. Because you have to turn the code into an invocable state machine where you can come back and then continue executing down here. And JavaScript doesn't even have go-tos, you know, and so you gotta actually like sort of make your way in with like switch statements and fake while loops, and it becomes spaghetti immediately. And if there's one thing that we're very cognizant of with TypeScript, it is we want to generate beautiful code that you can immediately recognize as being your code. And this would not look like your code. So So it's not likely that we will do it down level, but we certainly could do it for ES6 targets. Yeah.
Excellent. So now what do you think of, so one of the cool things about WinJS, besides it being sort of a, an abstraction library for interacting things on Windows, but they have kind of a robust async model using promises, right?
Using promises, and the way you should think of async await is that in C# we have async await, and then we have tasks. Tasks are basically the same as promises. They are, or futures or whatever, they are, a promise to deliver a value in the future and call a callback when the value is available. So they're just called promises in JavaScript, but they don't absolve you from writing your code as callbacks, right? I mean, when a promise completes, then you have a then method where you then give it a callback, and that's where you write the code that you want to execute when the promise is ready with its value. But if you want to try to wrap, say, a for loop around some promise delivering, and all of a sudden your head explodes, and it's because it's everything is inside out, and it's just now you got to write yourself a state machine, and that's non-trivial. And that's where async await can sort of do all of that hard work for you and basically remove all of your callbacks and just make it look like linear code, and then we generate a state machine that actually can be a target of callbacks, right?
Cool.
Yeah.
And the return is always a task, right? From async await. Isn't that what you get? Isn't that how it works?
Sure. Yeah. Okay. And that's so in a speculative. I mean, if and when we do it for TypeScript, yes, we would obviously base it on promises.
Sure.
Yeah.
So Nick would love to know, do you think now that Roslyn is open source, the C# language specification is open source as well, there might be a chance for browsers to support it as a scripting language?
It's possible. I'm not going to say it couldn't be done. I will say that it's very hard to create other languages for the web. We've all tried, with Flash and Silverlight and whatever, it's I think the web has a tendency to win there because it may be broken, but it's not broken enough, and it's supported everywhere, right? So I don't think we're going to see a lot of that necessarily, but it's certainly possible. Yeah.
Right on. How easy, hard is it to leverage Roslyn to create a new language from scratch that could compile to compatible CLRIL?
Well, I think you could learn a lot from Roslyn, but obviously Roslyn is not an abstract compiler framework. Roslyn is two compilers, a C# compiler, a VB compiler, that shares some common infrastructure on the bottom and shares a language service on top. So it's sort of in that sandwich we have two compilers. And you can, of course, learn a lot from what we've done in those compilers. And they are very interesting architecturally because, if I may geek out a little bit here on that, traditionally compilers, and if you pick up a compiler book, or go take a compiler class at a university, right? They'll teach you how to write a compiler in the classic sense of a scanner and a lexer and a checker and an emitter and whatever, right? But it's all very batch oriented, Code in, magic happens, object files out on the other side, and promptly you forget everything that you knew. But if you look at how we work with code today and how we work with compilers today, really the way we use the compiler is it is the brain behind the IDE that is running at all times, producing semantic information that then powers features like IntelliSense, refactoring, go to definition, find all references, and so forth. And there's precious little, in fact, I don't even know of any. There's literally no literature on how to construct that kind of a compiler. Now, certain things you share with a traditional compiler, like of course you have a lexer and a scanner and a parser, but you need to be incremental. You can't compile the whole program every time the user presses a key, right? So you got to be smart about only updating so much of your information, right?
Sure.
And you got to be able to answer partial questions with broken source code, because when you're typing your code, it is by definition broken because, well, I'm in the middle of typing this call, so obviously I don't have my parens balanced and I don't have all the arguments there yet, but we still need to be able to give you meaningful information, right? So So in that sense, you can learn a lot from the Roslyn code base about how to write a compiler that is modern enough that it actually can deliver the experience that people expect today when they work with their code, right?
Awesome. Now, speaking of compilers for languages in use today widely, do you see any work being done? Bjork wants to know, any work being done for Roslyn going into the VC++ compiler, regarding going open source and having it. So it's actually, the question is, it certainly could be useful for other languages besides VB and C#. And you could extend the question to be, what have you learned from building a compiler infrastructure that's programmable that could be applied to other languages?
Yeah. Well, I mean, so first of all, we're not actually the first .NET language to go open source with this kind of architecture. F# has been open source for years now. And has been an inspiration for us in many ways, like in the language, in their approach to everything. So we're learning from them. But I think there's just, like I said, many learnings there that could be applied also to C++. And obviously in the TypeScript project, we've learned a lot from what we did in Roslyn, and we've applied that there. So it's all sloshing around. Yeah.
Excellent. So, Dave, that question is sort of, I don't know what you're talking about, Dave. Alex would like to know, do you foresee features being hatched and implemented entirely by the community, ever making the physical? So that's the third time this question has been asked. So basically, the community can help drive C#.
I will predict right now that there will be some features that we will take that were entirely community driven. I'm hoping that that's the case. Because that would be, I don't know. I mean, it's like that just means that truly the community is engaging, right? And that's what we're aiming to do here. So,
awesome.
Yeah.
And by the way, there's been a ton of pull requests already from your announcement today. Yes.
Oh.
A bunch of
pull requests.
Well,
or
traffic forks. Forgive me.
Forks. Yeah. I mean, that's pretty fast.
I was going to say.
I know.
Okay,
fine. Yeah.
Remember when you went out with TypeScript, how fast that happened?
It's going to happen quickly, no doubt. Yeah.
Right on.
Yeah. Can't wait.
It's a wonderful thing. So Joshua wants to know, who is using TypeScript at this point in time within Microsoft?
Within Microsoft, lots of groups actually. Almost every group in Microsoft is in one way or the other using TypeScript. Like some marquee customers and apps that you might know is Xbox Music. All of the new features, they completely rewrote the experience of Xbox Music for Windows 8.1, and that was all done in TypeScript. We use TypeScript in Visual Studio Online. We use it in TFS. We use it in the F12 tools in Internet Explorer 11. When you press F12, you get the developer tools. That's all written in TypeScript.
Really?
Yeah.
Nice.
The Monaco tool set, the playground that we have in our TypeScript website is actually just a cut-down version of a bigger project to create an entire development experience in the browser, and that's all written in TypeScript. We have use of it in Office, in Bing.
Cool.
Yeah.
Well, your fellow luminary, if you will, Eric Gama, has been working on that.
Yes.
So I'm sure
he gave a great talk yesterday.
Yeah.
Watch it online if you didn't have a chance to go to the talk. Yeah, it was basically talking about his experiences of adopting TypeScript before we were even public. So they've been with us from the beginning, and we put them through a lot of pain, changing the language and changing the syntax of classes to align with ES6 and whatever, and they just endured. And they're just the greatest partner we could hope to have. Yeah.
Awesome.
Yeah.
John wants to know, what do you think of the design of TypeScript modules and the status of ECMAScript?
Yeah, it's interesting. We really wanted to align with the ES6 modules for TypeScript 1.0, but ES6 modules are still sloshing around, and it's one of the last things to get nailed down. There's still a bunch of debate in the committee about. Well, I mean, it's hard. I've always felt that it was important for modules to support the existing practices in the industry. So JavaScript may not have manifest modules in the language syntax, right? But there are certainly ways of doing modular programs. So Node.js has a module system called CommonJS. That you can write modules, and then you use a function called require to import a module, and the loader sorts out all of your dependencies automatically. And there's a browser-based version of CommonJS called the Asynchronous Module Definition, or AMD, which is and there are a number of loaders that implement that specification. The most popular is probably require.js. We support both of those in TypeScript with module syntax on top, right? ECMAScript 6 is moving a different direction and has chosen not to be compatible with the existing module systems, which we'll see how that goes. I hope that we can find a way to do all of it, because I really think, it's important for a language to evolve along with existing practices.
Sure.
Yeah.
So it actually brings up an interesting point in some sense. How has TypeScript influenced the direction ECMA is taking? Has it?
Possibly. Okay. I know that the arrow syntax that we have in TypeScript, we were experimenting with that and proposed to the committee that maybe this could be one way of doing it, and that ended up getting adopted. No, it's all, we're not the first ones to, I'm not going to try to, claim that we invented lambdas here. They've been around for a long time, but using the fat arrow and the particular syntax is exactly the same as we have in C#, right? But we have a wonderful working relationship with the ECMAScript Standardization Committee, and so and I respect. I think that it's hard to do language design in a committee. Trust me, I've been there. It's really hard. Because the last thing you want is for a thing to be a compromise, right?
Sure.
And that's basically what a committee sets you up to deliver. So I'm quite impressed with the work that's been done for ES6. It's ambitious, mind you. I mean, that's an awful lot of features in one release. But we're committed to making it work with TypeScript also.
Great.
Yeah.
I mean, if you think about all the hacks in JavaScript to do things that it really wasn't designed to do, it could be worrisome to deliver something that breaks the sort of daisy chain
but these
of breaking.
features are going to be delivered piecemeal. That's the good news, is that it is sort of a bag of separate features that browsers can go implement one at a time. You don't have to.
Excellent. Any plans to add F# support to Roslyn? Of course, F# already has its own compiler.
Well, F# already has its own compiler and infrastructure that isn't really that different from Roslyn. Roslyn is just a code name that we gave to the C# VB effort there. I think in spirit, they're really the same thing.
Cool. Is an actor model coming to C#? So we can start talking about future now of your baby.
I'm not sure that we would ever make a thing like actors manifest in the language syntax. I mean, I think you can build a lot of it with frameworks. And really, in a sense, I think the way that we would want to do something like that is we would look at, well, what are the sort of the linguistic pieces that an actor is built out of? Well, you've got messages and you've got whatever, and then so are there things that we could do to make it easier to write message-driven apps, for example, in C# without mandating a particular execution model? I think that's always dangerous when you say, here's my language and it supports actors and roles and whatever and this and that, and now you sort of painted yourself into a corner, right? In that if that turns out not to be exactly right, well then, again, you can't get rid of it, right? So you really want to try to break it down into things that have multiple uses. And then you want to make it so that you can compose frameworks out of those pieces that give you a variety of different programming models, right? And that's sort of what we're trying to do. So yeah, but we're certainly familiar with it. It's interesting stuff. Yeah.
Cool. And speaking of actors, yesterday the Orleans talk, they're implementing an actor-like framework. And of course, that's C#, and it is actually really brilliant what they've done. Yeah. With the grains and
it's cool stuff. It is. Yeah.
So Craig Johnson, with the amazing announcement of open sourcing Roslyn, can you help the community know more about the process of submitting pull requests to best work with your current language development process?
Yes, I can. In fact, if you go to roslyn.coplex.com, on our landing page, there's a link to, or maybe it's one down, but there's a link there to a page that describes the criteria that we apply to ourselves and that we will apply to the community when considering pull requests. So, cool. Yep.
Al, welcome back. You know, Al, you've not been asking enough questions. Felix, come on, man. Where have you been? Are you nuts? So, Al, thanks for coming. Will there be plugin support for language features in the Roslyn compilers at some point? Plugin features.
Plugin features. It's every time we try to think about what that might mean, we get very confused. You know, I don't know of a good way to have a plugin model for language features. Because language features tend to affect every part of the type checker, and they sort of like, I don't know, interact with other language features, and then you got to consider that, and so it's very hard to just have things that just sort of plug in and are separable, right? I think we also have to be cognizant of the fact that we don't want every program to become its own programming language, right? Because now we can't reason about what code does when we look at it, and we can't share code because, oh, well, that only works if you have this. I mean, so I think it's important that there be some core kernel of the language that we all agree this is what we're reasoning about, and this is what we use when we write our programs, right?
Yeah.
I'm a great fan of abstractions in the language, like attributes, for example, that maybe you could envision a meta-programming model where you put attributes in your code that then can cause a code generator to generate more code, but ultimately the language itself would be the same, right? Okay. But the way you orchestrate the creation of code, generation, transformation of code could be interesting to look at. A plugin model, yeah.
So what's your take on like sort of templates for C# where your
Sure.
genericity is more like that?
Yeah, I mean the problem generally speaking with templates is that they typically do a poor job of allowing you to flow the semantic information in your program. They tend to be more macro-like, right? And that's always been the problem with macros in C#, sure. and even with templates as originally conceived in C++ is that they really at heart are macro expansions, and they don't actually understand, in a sense, what's happening to the code, right? I mean, they just expand the code and then compile what resulted from that, and then you get super cryptic error messages, right? And now you don't know, well, why? What do you mean by this, right? Because the semantics weren't incorporated, and that's the harder part, Yeah.
Awesome. So this is Alik wants to know: is Roslyn slower or faster than the old compiler?
Right. It depends. There are cases where we see it being a little bit slower. There are cases where we see it being faster. I would not expect for you should not expect to see slowdowns, really. You should expect it to perform the same. But one thing that we can do much better now is take advantage of multi-core architectures. Cool. Because of the way we've architected the compiler is actually, it's an interesting architecture because internally it heavily uses immutable data structures and is written in a very functional programming style, if you will, where it's possible for us to share data structures between multiple threads of execution without having to worry about mutation from one causing side effects in the other. And so things like generating the IL for method bodies, for example, can be totally farmed out to as many cores as you have available because they're completely separate tasks. They all refer to a common symbol table, but that symbol table is immutable, so hey, no worries there.
Cool.
That used to not be the case in the old compiler. The old compiler could only execute on a single thread.
Wow.
Now, so you could parallelize builds, but you couldn't internally parallelize. And that we can do now, and because we can do that, we often see that things go a lot faster because we're just better able to take advantage of the 4 cores that you've got in your box anyhow.
Or the 8 cores,
or
right?
whatever, however
or the
many.
16 cores.
Whatever, you bring them.
Or the hundreds of cores on a GPU, man. Why can't you use
we're
the
not
GPU?
we're not doing GPU execution.
All right.
That's a whole different ballgame. Yeah.
All right, so we're about the last 2 minutes. We have more questions. I do want people to know out there that we're going to continue this conversation. It'll be on demand on Channel 9, so we'll try to get to all your questions. They just won't be live. So keep on asking them, and thank you. Let's go ahead and let's see. Primary constructors in C# vNext are awesome. Do they have a body for arguments, checks, etc.? Do class parameters, are they captured into fields implicitly or explicitly like in TypeScript?
Right. Well, thanks. Yeah, they are a fun feature. We're still debating whether to have the ability to write a body where you do additional code over the automatic sort of initialization that we do of fields. Are they captured into fields? They are captured into fields explicitly. We actually we started out with a model of implicitly capturing primary constructor arguments into a field if you reference them in another method, which can be super handy, but it's very hard to know when it happens, and because it does affect the size of your instances, because we capture it. In particular, when you then have hierarchies of inherited classes, we may end up capturing the same parameter multiple times in each level of inheritance, and ultimately we decided it's better to do it explicitly.
Okay.
And so now you can add a modifier to a primary constructor argument that makes your argument into a property or into a field in the class, and then you can use that. So, but it's a fun feature. It allows you to write more succinct code, definitely.
Cool. Yeah. And it's clear that Alex maybe has been looking at the
He obviously has been looking at it. Yeah.
Right on, Alex.
So yeah, and it's in there. So in the Roslyn repo that we open source today, the C# and VB compilers already implement a number of upcoming features. Of course, we haven't said yet that these are going to be official, and they may change. And so if you take a dependency on them, you should expect your code to break, possibly. So be careful there. But they're in there, and we even have a little page that summarizes which features are implemented and which ones are still being considered.
That's actually a really interesting side effect of open sourcing Roslyn, because now you're going to be able to slip features in and use it as a way, in a lightweight way, to vet whether or not they make sense. So now, rather than we're going to have this big release, ship with the next version of Visual Studio, you're like, hey, Andrew sends a note. I just created, destructors in C#. What do you guys think? Right? So we're going to keep going. All right. Marcus, would I be allowed to clone and push Roslyn up to GitHub?
Absolutely. It's open source, Apache 2.0. You can do with it whatever you want. I mean, as long as you include attribution, Yes, so you can put it on GitHub. In fact, I'm sure someone already has. I saw before walking up here that there were more than there were some already 10 or 11 forks have been created, in places. So
awesome.
Yeah.
Rabid Coder is back. With C# around for close to 15 years, has backwards compatibility restricted you from adding any feature you wished you could?
Yes, I would say so. I mean, I think I've talked about it before. It's maybe not so much that C# has restricted us, but the whole, .NET framework and ecosystem. I would have loved to have non-nullable types in the language, non-nullable reference types, because null references are a big source of bugs, right? And if we could do a better job of reasoning about those in the type checker, then perhaps we could reduce the number of initial bugs you initially have to deal with. But it's very, very hard to fit a feature like that in when everything implicitly is nullable today. And the only way that we could push it in would be to sort of crank up the type checker in the library and break a bunch of code and require people to go in and reason about it, and that just can't happen, right? So some things you're just going to have to wait for your next chance, and then put them in then.
Cool.
Yeah.
Mark would love to know, any love for tuple unpacking in C#, like var x, y equals get coordinates and get coordinates, returning a tuple?
Yes, there's love for it. We still think about how to best do it. the thing that has been a concern in the language design group is that we already have anonymous types. And they're, in a sense, very similar to tuples, except that the fields have names, where in a tuple, they don't have names. But that's really, in a sense, the only distinction. But if we have both, then it's like, well, which is it going to be, you know, and like should we have people do one or the other? And so that's something to consider. But, you know, I think tuples are interesting, and then who knows? Yeah, we're still thinking.
Right on.
Yeah.
I mean, I think it should be clear to everybody that you're still thinking deeply about C#. I'm surprised that no one's asked questions like, what's coming in C# 6.0? What are the big features? You showed the little one today, which was nice.
I wouldn't say that there are any super huge features currently, just because we've been so focused on building the new compilers, getting them to production level. You wouldn't believe how hard it is when you have a community of, I'm gonna venture to say there are billions of lines of C# code out there, right?
Nice.
A community that's 15 years old, has millions of programmers in a day-to-day producing code, right? And they all use this one compiler that, you know, didn't necessarily in every minute detail implement the spec that we wrote down. So and now you build a new one, and we've made a promise not to break code, right? But what if the old compiler did it wrong, according to spec, but people have taken a dependency on it? Now you got to consider, well, should we modify the spec? Should we do this, do that? And even though it's clearly not meaningful, you might still have a dependency on it, right? And so there were a lot of examples of where we really had to consider, you know, like, it's like, pick your poison here, right?
Sure.
So that has taken a while, but we're there. We're now actually, I don't know if I said it already, but in-house, we're using Roslyn for building all code in the developer division. They are now our production compilers. Yep. And that's sort of going to roll out once we get to the next version of Visual Studio. Those will be the compilers, but you can play with them today even, and you'll find that they are a very, very high quality. I mean, we've set an extremely high bar for ourselves there. Yeah.
Right on. So
did I answer? What was I got off on a tangent.
No,
what was even the question here?
No, it's a great tangent.
All right.
It's an excellent tangent. Right. It was the question was about it's gone now, but you answered the question.
Okay, good.
So, TypeScript is a superset of JavaScript. Why is MS not creating a superset language for CSS, like less?
Well, maybe we should look more at ones that exist already, right? I mean, I don't know that we necessarily want to create a new superset of CSS, but we could indeed consider, you know, supporting some CSS superset or in our tool set. And that's something that's been talked about. It's not something that we've done yet, just because, again, there's so much work to do and only so many people to do it, right? But I think it's interesting to apply the same philosophical thinking to style sheets as it is to programs. You know, there are ways with annotations that you can make these things checkable before you deploy them, right?
Interesting.
Yeah.
So catching CSS bugs at compile time.
Yes. Yes.
Statically compiled CSS.
Yes. Well,
very
you
interesting.
can even think about that for HTML too, right?
Sure.
I mean,
but is CSS a language? I mean, is it a?
It is, but it's more of a declarative language, right? I mean, it doesn't have imperative executing constructs per se, but yeah, it is a language.
But it has like classes and inheritance, which are not the same.
It does have a form of that. Yes.
So, Hadrian, is it possible to use the Roslyn compiler to pre-process C# code at compilation time in order to generate code?
Yes, although it is certainly, well, when you say pre-process C# code at compilation time, you could create your own compilation time where you use Roslyn to do things with the code, right? I mean, you can parse the code, you can use those parse trees to do your own transformations. There's nothing in the current execution pipeline of the compiler that allows user code to be injected into the different phases of compilation. Currently, there's no plugin model for that. But I alluded to that a little bit earlier, you know, with this notion that that we've thought about from time to time of allowing people to put attributes in their code and then have those attributes execute at compile time and participate in generating more code based on the semantic information that the compiler has so far collected.
Cool.
That's still something we're thinking about, but that's sort of the overall idea, right?
So is that sort of a variant of metaprogramming?
It is a form of metaprogramming, yeah. Attribute-based metaprogramming.
Excellent.
Yeah.
So Lauren, okay, so people have, look, Joe Duffy did a blog post, talked about something called System C#. It was an excellent blog post. It's great that they're working on that. There's nothing really official that Microsoft can talk about, but so to answer your question, Lauren, I guess we can answer your question, but yes.
Well, I mean, we could answer that.
Okay,
question.
let's read it out then. Are there any language projects at Microsoft that are targeting a similar paradigm as Rust? Native, type safe, compiled, no garbage collector.
No garbage collector, yeah. No, not specifically.
Okay.
We've had some internal projects that have been talked about from time to time. There was a research project called Sing Sharp. We've had an internal project called Midori or System C#, about using C# as a systems programming language. It's not something that we have productized currently, out of sort of fear for creating multiple C# dialects and how to manage that. And also these were not non-garbage collected languages. So far that's just not where we have focused. I think we actually had Bjarne Strustrup came and gave an interesting talk at Microsoft just about a month ago or 6 weeks ago. And I think the work they've been doing in C#11 or C++11 is pretty interesting. So
totally.
There's some good stuff going on there. So I would urge people to look at that too.
That's a great point.
If you're looking at Rust, then C# is not dead and gone, or C++.
So not at all. And so C++ 14 is even better in that lens. So
yes.
But it's an interesting question, and it kind of brings up another question about could you create a variant of C# that's native? So you take the .NET native thing a step further.
Right.
You're not bound to the BCL like it is.
Right.
But you take C# code and you're like, you know what? I'm going to produce. With no garbage collection.
Well, that's the tricky part, right? I mean, absolutely, you could take C# and not take the BCL or the framework, right? And you could create your own base class. I mean, the compiler has very, very few dependencies on the frameworks. Yes, there has to be a string type, and there's certain names that you have to pick for the primitive types. But other than that, you can pretty much do anything you want in the framework. Now, getting rid of garbage collection is a different proposition, because your code would look very different if you had to manually dispose all data structures that you create in the language, right? Like, arrays, you would have to go dispose. There is no inline array, stack allocated array. They're always a reference type, and that means all arrays are heap allocated, and therefore all arrays must be disposed, right? Strings, likewise, and so it would be painful to not have a garbage collector. I mean, the language really has the implicit assumption that someone is doing the garbage collection behind the scenes, or else it's no longer really C#.
You got it. And it's no longer a managed language.
No.
Right?
Well, I mean, it depends on what you mean by managed. Managed means many things, right? It means, in our world, it means garbage collected. It means type safe, I think, so type and exception safe and whatever. And manage could also mean, that you can orchestrate your code and the loading of your, it's like, it's an ill-defined word.
Right on.
Yeah.
All right, so Paul Sorensen wants to know, good or bad idea, use Roslyn to generate TypeScript classes based on C# model classes with some custom attribute.
Well, I think that's what I just described, so it must be a bad idea.
Why is it a bad idea?
No, I don't think it's a bad idea. I think.
Right on. So, whatever wants to know, I'm really happy for the source code of Roslyn. Despite that, I have a question. First, in the later C#, you see infinitive arguments, number, IUnumeral, blah, 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 variadic templates, and C++. Can we implement them by the source code? So I think
I am not quite sure what that means. If it's I mean, I think maybe we're talking about params IEnumerable here is my guess.
Okay.
So right now we support params arrays in C#, but one of the oft requested features is params IEnumerable. I believe we already have that implemented in C# 6.0.
Nice.
It's certainly, it's a small feature, but it would allow you to basically treat parameter arrays just as enumerables.
Okay.
Yeah.
And
Yeah.
so with variadic templates, you get a variadic number of arguments for your template constructor.
Well, if we're talking about type arguments, we're not doing that. So I'm not, but I'm not. I can't quite parse what the question.
Translate your question again and repost it, Volbus. Thomas, are there any Easter eggs in TypeScript 1.0?
Not that I know of. And if there were, I wouldn't tell you.
Right on. Daniel, as you say, language design by committee is difficult. Do you expect it to be more difficult to guide the design of C# VB now that Roslyn is open source?
It's a good question. I don't know. I don't expect so. I mean, I think hopefully people have, you know, I mean, I think people respect the decisions that we've made for C#. You know, I think we've been reasonably good stewards of the language in the 15 years that it's existed, and that I trust the community will still see us as the caretakers of that. But you know, we always want to engage with the community. I mean, it's like, I mean, they're our lifeblood, right?
Sure.
So it's not about us telling you what you must do. It's a dialogue. And I do expect that it'll be different, you know, with open source, and that we'll have even better, more constructive dialogue with our community. Yeah. Excellent.
Mm-hmm. Thorium, now it seems that C# libraries are having overloads of generic funct syntax, and then async versions of them. Would there be partial application or monad support to rescue our interfaces?
Gosh, I wish I knew what that meant.
Is that you, Eric?
No. Not sure on that one. I do understand that we don't abstract over a variable number of type arguments, which in a sense, you know, if you look at the func types, like we have a whole family of them up to some limit of T's, right? I think it's 8 or maybe it's 16 we go to, right? And then of course there's always someone who needs one more, right? And so wouldn't it be nice if we could abstract over any number of type arguments? And so when you get into this sort of higher ordered types of abstractions, it gets very abstract, basically, and very hard to implement. And it's not clear that there's a whole lot of yield there by us going there, but you know, if there's a specific problem, we'd love to you know, ask us on our discussion forum on the Codeplex site, and we'll see, you know.
But I really want to implement variadic funcs. You know, the like variadic templates.
Get with it, Charles.
I'm just
kidding. Put up a pull request.
Can you imagine that? All right. So Kira would like to know, are you aware of such amazing macro-based C#-like language as Nemerle, where all control flow structures like for and while statements are implemented as macros? What are your thoughts about bringing similar macros to C#?
I am familiar with it, yeah. I'm not sure how possible it is to do all statement constructs that way. And again, I do worry about people creating their own dialects where every program becomes its own programming language. I think, you know, for better or for worse, today in C# you can instantly recognize, you know, that this is a statement, there's a for or an if or a while or a do, and there are only so many of them, and then there are calls. And calls can then have arguments, and they can be lambdas, and you can express a whole lot of things, but when you look at a code, you know what you're looking at. Do you know what I mean?
Yeah.
But if you start adding like pluggable and people dream up like 20 new statements then, and you look at a body of code, you're kind of gonna go, what am I looking at here? You know, so it's a tough one. I mean, it's something that we continue to look at, but we haven't gone there yet.
Sure.
Yeah.
And of course, again, they could take it there.
Sure, and maybe someone will, and then we'll certainly look at that. Yeah.
Awesome. That could be the tagline for C# now. You could take it there.
That's right.
Avi wants to know, what do you think about computation expression from F#?
Yeah, they again are sort of one of these high-level abstractions that, you know, I mean, we support an application of those called asynchronous methods, you know, which in a sense allows you to orchestrate. It allows you to, in a sense, be God and orchestrate execution of a body of code, and then at given points have the code stop and yield control back to you, so you can modify its environment and whatever, right? And F# has taken it to sort of the next level and abstracted that out as a feature that you can then apply different forms of execution environments to. And that's interesting, but it's also somewhat abstract, and we've chosen not to go there. Well, kind of, we can sort of go there a little bit with expression trees where you can decide yourself how to execute them. You could speculate that maybe we should do statement trees as well as expression trees, but again, they have a heavy dependency on reflection, and reflection isn't always available, and so there are all these different considerations that, you know, so far we've just sort of tried to stay with pragmatic applications of stuff that solves a real world problem, you know.
Awesome, great answer. Let's see here. Can we have yield return async iObservable soon? John asks.
Return async iObservable. Oh, iObservables. Possibly. iObservables is sort of gets us into reactive programming, and it's really sort of a different way of doing a lot of the async programming. I'm personally pretty happy with what you can do with just async await currently, and I'm not sure exactly how it would tie in. But I'd love to see a proposal. Then you know, or why it's important. Yeah.
Totally. So John, go ahead, download the Roslyn source code, implement it yourself, man. Take RX, and then figure out how to implement it at the language level. Chris wants to know: will you add support to code server-side TypeScript in ASP.NET MVC apps? Server-side TypeScript.
Server-side TypeScript, probably not in ASP.NET MVC apps, other than, I mean, you could call code from ASP.NET MVC apps using Node, for example, but you probably would go through like a normal service invocation at that point, pass a JSON document, whatever. So it's, I'm not sure that we would get it in super deep, because ASP.NET is a, you know, it's managed code, C#, VB, or whatever, you know, framework, and Node.js is a whole different execution engine, and whatever, and you'd have to go between those two. But certainly we do support Node.js, so yeah.
So now we can get, this is great. I mean, so SG actually asked a great question. You know, Nick sort of can take it. What is the next step you would like to take to create next generation programming language? So do you ever think about creating a new language? Like, would you like to create a new language? Do you want to have more kids?
I have 4 kids, that's plenty. And I've worked on lots of languages. I love languages.
Sure.
But sometimes, you know, like I mean, the world needs another language like it needs another hole in the head, right? I mean, we have lots of languages, and I'm not in it just to create languages, really. I'm in it to make programmers more productive, right? And often that means creating languages, but sometimes it means creating supersets of languages, right? Or creating better implementations of existing languages, or what have you, right? So in that sense, I'm agnostic. You know, it's fun to dream up new languages, but keep in mind that whenever you dream up a new language, 90+% of what you're doing is the same as in every other language, and you're just like putting a different spin on the same problem, right? And then there's maybe the little net new that you end up doing. But a lot of it is really just like, and a lot of new languages tend to neglect the meat and potatoes, you know, of, hey, you gotta have like a real type system and a real this and a real that and whatever, and that's just sort of not necessarily new, right? Also, I've always felt that if you can superset something, like for example, like we did with TypeScript, right? Then boom, you have an enormous community of stuff that just works. Like, I mean, the beauty of TypeScript is the fact that it works with all of the existing JavaScript frameworks, right? And that's just massive.
Yeah.
You know, and people don't have to start from scratch. They just have to learn these extra features that you've added. They have to relearn everything they already know, right? So sometimes yes, sometimes no. I don't know which language comes next. You know, if it's hard to say. Yeah.
Right on.
Yeah.
Well, I mean, it's a really interesting space. And I like this. Any plans to move Turbo Pascal into VS?
Well, that would be fun. You know, I believe you can actually like get a copy of Turbo Pascal out there. It's you know.
I think I saw the floppy disk.
Yeah. 32K that product was.
Impressive.
I did the math. Someone blogged about it somewhere. Like the original Turbo Pascal is a third the size of today's jQuery in minified form. And we're talking about an entire editor, compiler, runtime library.
Amazing.
That's a third the size of minified jQuery, right? That was back when programming was a craft.
For sure.
And you had to like write it all in assembly, and you know, those days were good, but they're long gone.
They are.
Yeah.
Right on. I mean, it's a nice thing that those days are gone for lots of people. So what is the advantage of TypeScript over SharpKit, Script Sharp? Did you try any of them?
Oh yes, I did. I'm actually not so familiar with SharpKit, but I'm quite familiar with Script Sharp. Yes, I played with them, and yes, we deeply considered that as a possible strategy for our JavaScript tooling. You know, this notion that you would write in C# and then cross-compile, which of course would be wonderful if you're a C# coder, but which of course also would be fairly uninteresting to the web at large, right? Because, well, they're already writing in JavaScript, and we're not going to switch to C# so we can, I mean, why would we do that, right?
Sure.
So in a sense, I think we quickly realized that if you want to be best of breed in a particular community, you got to go with what's synergistic with that community. You got to find ways to not change that community, but to strengthen that community. And that was right from the get-go. Our intent with TypeScript was really just let's just find ways that we can make JavaScript better for large applications, right? But we're not in the business of, oh, forget about JavaScript, treat it as an IL, and then write in this language over here. Yeah, well, that's all very nice, but then what if I want to use this new JavaScript framework? Then, well, what do I got to do now? How do I make that into my other language? Well, you can't. Well, then why is it interesting, right? So, yeah.
Cool. We're going to wind down here now. I mean, poor Anders is probably getting tired, but I know, you know, Larry's like, wake up, Larry. No, I'm just kidding, man. So, anyone have any more C# questions? Come on, guys. So what do you think about Clojure? And do you think that Clojure can become a first-class supported language on the CLR? Now, I know he did actually do a little work initially with Clojure running on the CLR.
It's entirely possible to do that. I mean, I like functional programming languages. You know, I think they're very interesting. I'm not sure that I like that particular syntax all that much. You know, but I mean, I sort of prefer my curly brace style a little bit more. You know, I think, but but yeah, absolutely, it's possible.
Okay, so we got 9 questions in the queue. So we're going to try to kind of go through these so that you can hear Anders answer them. Is there any hope for operator overloading with TypeScript? That's from Gabriel.
I'm gonna guess no.
Okay.
Simply because we aim to be, really complementary to JavaScript, and JavaScript is not planning to add operator overloading, and it's not clear to me that it's really worth it to do that necessarily. Yeah. So I think we're good where we are on that one. Yeah.
Good. So Rajiv wants to know, do you love F#, Anders?
I absolutely do. I think I mean that it's of all the places from which we have gotten inspiration in C#, I can't think of anyone that ranks higher than F#, right?
Wow.
I mean, well, it's true. I mean, all of our functional programming stuff was deeply inspired by F#, and F#'s been open source, and they've been very, very forefront, and they've done excellent work, and so yeah, I'm a great fan of F#.
Awesome.
Yeah.
Ron wants to know, will Roslyn make it easier to have a portable code base that'll run on any platform?
Yes. I would absolutely think so. I mean, of course, it doesn't solve every problem, but with Roslyn being open source now, there is one compiler that can be run anywhere that C# code can run, which means, on Microsoft platforms, and with Mono, it can run on iOS or Android, or Linux. So, and it's the same compiler that you can run now. So you can be assured that the code you compile here will compile exactly the same over there.
Awesome.
And that's valuable.
Of course.
So yes, I think it makes it a lot easier.
I mean, how do you feel? I mean, in some sense, you designed C# initially, basically at the same time that .NET was evolving, and they sort of were born together and grew together.
Yes.
And now C# has become a language that people are using to write iOS apps, Android apps, thanks to Xamarin.
Right.
Thanks to Xamarin.
Yeah.
But I mean, that's pretty amazing.
Yeah, but underneath that, of course, is a framework that is basically the same as our framework, and we use the same IL and the same execution infrastructure with the same semantics, and so there are much deeper similarities than just the C# syntax, right? But we're moving more and more towards sharing the same assets, and every time we get closer to the same assets being shared, we stand a higher chance of succeeding in having the same result when we execute our code, right?
Sure.
Yeah.
Excellent. So Roland wants to know, I see extremely little comments in the Roslyn source code. Is there a reason? Did you remove all the comments before you guys went open source?
No, I think there's just a limit to how many comments there was time to write, I mean, and hey, that's something that the community could help fill out too, right?
Right on.
So, yeah.
Comment the code, man. So Fan Baby, I definitely recognize the Niner name. You're doing a lot of open source lately. Have your views, Microsoft's views on open source through the years changed? I mean,
well, absolutely.
Obviously.
I mean, we used to be a lot more proprietary in our views of the world, and ultimately we're here to serve the developer community. And when the developer community gets excited about a certain way of doing it, it does not benefit us to try to do it differently, because then the developer community will abandon us, and we do not want that to happen, right?
No.
So we fully understand the value of open source, and I think we're getting better at it every day. It's a journey. It's a learning experience, right? And we're saying, listen, we're willing to play, we're willing to learn, we're in it. We're all in it together.
Awesome.
Yeah.
We're giving Windows away for free on certain devices.
That's right.
I mean, come on, man.
Yeah, really.
Yes, we're changing. We get it. This is interesting. So C++ has C++ AMP, right, which is the language extension for C++, so you can target the GPU. Is C# going to get something like that at some point?
I would expect to see it more as a framework thing than a language thing. Would be my opening posture on that. I mean, C# is actually very, very expressive already, right? I mean, and the fact that we have expression trees and whatever, it means that you could create libraries to which you can pass code that you would like to have compiled and executed on a GPU with full type checking and everything. All the pieces are there, right? So I'm not sure we need to have new language features per se, but there are definitely new framework features that could be interesting. Yeah.
Interesting.
Yeah.
I mean, it would be interesting to see. We've already asked that question. Right, we're going through the thing now. So are there any plans to create a built-in library that ships with TypeScript?
No. TypeScript is about strengthening JavaScript, and TypeScript's library is JavaScript, if you will. Or we're not going to be in the business of creating new frameworks with TypeScript. I mean, that's not to say that Microsoft won't create new frameworks, but it's not going to be hitched to the TypeScript bandwagon.
Sure. Because that sort of would make much sense, right? I mean,
it would make more sense, or you think?
It wouldn't.
No. TypeScript is all about strengthening JavaScript and building better JavaScript tools and programming experiences.
Right on. Well, hey, speaking of building better tools and better programming experiences, thank you for all the incredible work you've done.
My pleasure.
For C#,
I love this as much as you do. Yeah.
Right on. And thanks for coming on Channel 9.
My pleasure, Charles.
Always awesome to see you.
Thank you.
Start building stuff. Roslyn's in your hands. Take the language where you think it should go. But it may not get there.